Recent reports from China indicate that CL, currently the largest battery manufacturer in the world, has unveiled a new generation of sodium-ion batteries with a staggering 1,200 kilowatts charging capability. This development marks a significant leap in battery technology and could have profound implications for the electric vehicle industry. Sodium-ion batteries, once seen as a potential but limited alternative to lithium-ion technology, are rapidly emerging as a viable competitor due to their lower cost, faster charging capabilities, and steadily improving energy density. The new battery pack from CATL appears to be an upgrade of its free void design, which previously combined sodium and lithium cells. However, indications suggest that the latest generation may rely entirely on sodium cells. The charging rate of 1,200 kilowatts or 12C represents a level of speed that was previously considered unattainable. This kind of performance has the potential to disrupt not only the battery market but also the broader electric vehicle industry, as such advancements drastically reduce charging times, improving the convenience and viability of electric vehicles for mainstream consumers. CL is not alone in driving this innovation. Other major players in China, such as BYD, are also advancing at a rapid pace. This puts battery manufacturers in South Korea and the United States under increasing pressure to keep up. The pace of development in China is particularly noteworthy, as it underscores the country's dominance in the battery sector and its determination to stay ahead of global competitors. A key example of this new technology in use is Huawei's EOEOA line. The ITA-MESIX, produced through a joint venture between Huawei and Series, will feature CL sodium-containing battery pack. This joint brand, operational since 2021, combines Series manufacturing expertise and platform design with Huawei software and components. Vehicles equipped with these sodium-ion batteries are expected to enter the market soon, bringing cutting-edge charging technology to consumers. The capabilities of these batteries are particularly striking. A slide from a recent presentation highlighted the 12C charging feature, meaning that a battery could theoretically achieve a full charge in as little as 3 to 4 minutes. Zoosh speeds represent a breakthrough comparable to the leap from dial-up internet to high-speed broadband, setting a new benchmark for energy storage systems. Two configurations of the vehicle are planned, one using a sodium-based ERV battery and another fully electric model utilizing CL's advanced GEN battery pack. The Gillen battery pack, also known as the CTP Celta 3.0, is CL's third-generation Celta pack design. This pack achieves an energy density similar to Tesla's 4,680 cylindrical cells at approximately 255 Wh per kilogram. What sets the Gillen pack apart is CL's claim that it can fit more cells per unit compared to Tesla's design, potentially increasing the vehicle's overall range. Early reports suggest that vehicles equipped with the Gillen battery pack could achieve ranges of up to 1,000 kilometers on a single charge, making range anxiety virtually obsolete for most drivers. There is also mention of a condensed sodium battery featuring MP 2.0 thermoelectric separation technology. This condensed battery is said to have an energy density of 450 Wh per kilogram, which is substantially higher than standard lithium-ion cells. A battery of this caliber with an 80 kilowatt-hours capacity could provide over 800 miles or roughly 1,300 kilometers of driving range. While these condensed batteries are not yet widely deployed in consumer vehicles, their introduction would represent a seismic shift in electric vehicle performance. Perhaps the most revolutionary aspect of this technology is the 12C charging capability, a 100 kilowatt-hours battery pack capable of handling 1.2 megawatts of power could be fully charged in under 10 minutes. This rate of energy transfer is virtually unprecedented and would require significant advancements in charging infrastructure, from power grid enhancements to new cooling and table technologies. The Shun-YNC battery, the latest innovation from CL, is a testament to the company's relentless pursuit of progress. The first generation of Shun-YNC was already considered one of the most advanced lithium iron phosphate batteries in the world, but the second generation pushes beyond even that reputation. With the ability to exceed 1.3 MW in charging speed, it challenges the capabilities of any battery currently on the market, including those from leading Western manufacturers. This rapid development raises questions about infrastructure readiness. Charging stations capable of delivering such massive power levels are not yet widespread. Most high-speed chargers today max out at 350 kilowatts, a fraction of what these new batteries can handle. The industry will need to adapt quickly to make full use of these capabilities. Innovations in grid technology, energy storage, and thermal management will all be necessary to support the shift to ultra-fast charging. The implications go beyond passenger vehicles. Batteries with these characteristics could revolutionize freight and logistics, electric trucks, buses, and heavy machinery. Sectors where charging time and energy density are critical stand to benefit immensely from sodium-ion technology. The ability to recharge large battery packs in minutes rather than hours could make electric freight vehicles as efficient as their diesel counterparts while reducing operating costs. Additionally, the advantages of sodium-ion batteries extend to grid storage solutions. Their fast charge-discharge cycles, low cost, and tolerance for temperature extremes make them ideal for stabilizing renewable energy sources like wind and solar. As the world transitions toward a low-carbon future, affordable large-scale energy storage will be critical, and sodium batteries are well positioned to fill that role. The next few years will determine how quickly sodium-ion technology can be scaled for mass adoption. CATL has signaled that these advanced batteries will begin appearing in electric vehicles within the next 6 months. If this timeline holds true, it will be one of the fastest commercial rollouts of a new battery technology in history. The combination of rapid charging, high range, and lower cost will make these vehicles highly competitive and could reshape consumer expectations worldwide. The widespread adoption of sodium-ion batteries could also alleviate some of the geopolitical and environmental concerns associated with lithium-ion technology. Lithium, cobalt, and nickel. Key materials in traditional batteries are often sourced from regions with ethical mining concerns or supply chain vulnerabilities. Sodium, on the other hand, is far more abundant and widely available, reducing reliance on contentious supply chains and lowering the environmental impact of battery production. Moreover, the scalability of sodium-ion production could drive down costs even further. With fewer material constraints and simpler extraction processes, manufacturers may achieve economies of scale more rapidly than with lithium-ion batteries. This affordability could accelerate the transition to electric mobility in developing markets, where cost remains a significant barrier to adoption. The potential applications of industries such as aerospace, marine, and even consumer electronics could benefit from the high energy density and rapid charging capabilities of sodium-ion batteries. Drones, for instance, could achieve longer flight times with quicker turnaround between missions, while smartphones and laptops might see drastically reduced charging times without sacrificing battery life. However, challenges remain before sodium-ion batteries can fully replace their lithium-ion counterparts. While energy density has improved significantly, it still lags behind the highest-performing lithium batteries in certain applications. Additionally, the long-term durability and cycle life of sodium-ion cells in real-world conditions need further validation. Manufacturers will need to ensure that these batteries can withstand years of heavy use without significant degradation. Another critical factor is the recycling infrastructure for sodium-ion batteries. As the technology matures, establishing efficient recycling processes will be essential to minimize waste and recover valuable materials. Unlike lithium-ion recycling, which is still evolving, sodium-ion systems may offer simpler and more cost-effective recycling pathways due to their chemical composition. Despite these hurdles, the progress made by CATL and other Chinese manufacturers demonstrates the rapid pace of innovation in the battery sector. The ability to bring such advanced technology to market within months, rather than years, highlights China's strategic advantage in clean energy development. Western automakers and battery producers will need to respond with aggressive investments in research and partnerships to remain competitive. In the broader context of global energy transition, sodium-ion batteries could play a pivotal role in decarbonizing multiple sectors. By enabling faster, cheaper, and more sustainable energy storage, they complement the growth of renewable energy generation. Solar and wind power, which are intermittent by nature, require efficient storage solutions to balance supply and demand, a role that sodium-ion batteries are well suited to fill. Looking ahead, the success of sodium-ion technology will depend on collaboration across industries and governments. Policymakers must support infrastructure development, including high-power charging networks and grid upgrades, to unlock the full potential of these batteries. Meanwhile, automakers and energy providers will need to integrate sodium-ion systems into their products and operations seamlessly. The emergence of 1,200 kilowatts charging capability is more than just a technical milestone. It represents a paradigm shift in how we think about energy storage and electric mobility. If CATL and other innovators can deliver on their promises, the next decade could see electric vehicles that charge faster than gasoline cars fill up, at a fraction of the cost and environmental impact. Ultimately, the rise of sodium-ion batteries underscores the dynamic nature of the clean energy revolution. As technologies evolve and new breakthroughs emerge, the possibilities for a sustainable future continue to expand, with companies like CL leading the charge. The vision of a world powered by efficient, affordable, and eco-friendly energy storage is closer than ever to becoming reality. International competition is certain to intensify. Companies in South Korea, Japan, Europe, and the United States will need to accelerate their research and development efforts to keep up with the pace set by China. Strategic partnerships, licensing deals, and new manufacturing techniques may emerge as other players attempt to close the gap. The unveiling of CL's sodium-ion battery marks a turning point in the evolution of energy storage. With charging speeds exceeding 1,200 kilowatts, energy densities approaching that of high-end lithium cells, and the promise of significant cost reductions, sodium batteries are poised to transform the electric vehicle market and beyond. This is not just an incremental improvement, it is a leap forward that could redefine what is possible for clean energy technologies.